Good morning, everyone, or good afternoon, or good evening, or whatever time it is where you are. We're very happy to have you attending our Global Engineering Education Seminar Series. Our talk today is by Professor Weisong Shi. It's on edge intelligence and its application to connected and autonomous vehicles. Dr. Weisong Shi is the Associate Dean for Research and Graduate Studies in the College of Engineering at Wayne State. He's also the Charles H. Gershenson, sorry about that, Distinguished Faculty Fellow and a Professor of Computer Science, and leads the Wayne Mobility Initiative, and directs the Mobile and Internet Systems Laboratory and the Connected and Autonomous Driving Laboratory, where they investigate performance, reliability, power and energy efficiency, trust and privacy issues of networked computing systems and applications. He's also the founder of the IEEE International Conference on Connected and Autonomous Driving, which is held every spring. And he's one of the leaders in edge computing research, computing, and has been a strong advocate for edge computing since 2014. So you're getting the opportunity to hear from someone who's very knowledgeable and a real expert on this field, and I think it'll be a great talk, and thank you for attending.
Thank you very much, Lauren, for the introduction. So as some of you that probably know that I have been running this Jessup series. This was the 7th this year. I noticed several of you has been an audience in the previous seminar series, so you know what this is. But in case for some of you are new to this, I will give a brief introduction to this. What is this seminar series? And then we will go to the talk. Earlier this year, so as this is part of our global engineering education, so one of our alumni, make this donation to us to support us to launch this, we call the Jessup seminar series with a total of 8. My talk is the 7th, and then next week we will have our last talk. So we have already put all of these previous talks on the, I believe already on the website, our website, and we are in the process of moving them to our College of Engineering YouTube channel. So in case you are interested in some of these topics, you are more than welcome to watch them back. I noticed that because engineering is pretty broad, although we always think about engineering like one discipline, but we have biomedical engineering, chemical engineering, mechanical engineering, electrical, and and computer engineering, even industry and system engineering, civil, and etc. So probably you are not going to be interested in all of them. But what I want to say here is, just like today's talk from this title, so you probably, if you go back 5 years ago, I don't even think that I will be working on the vehicle side, because we always think vehicle engineering is part of that mechanical engineering, is my colleagues there are going to be working on this. However, in today's world, things is changing, fastly, and many of these disciplines are starting, the boundary between them starting blurred. It is quite common. For example, in one of our previous talks with Professor Azad Ghaffari from mechanical engineering, he actually is doing control. He's doing control UAV stuff, and those traditionally you might think is sitting in the ECE department. So I think the beauty of this, the 8 series, is to give you a taste about what we are doing at Wayne State. Specifically those the speakers with their with their research tasks, and hopefully we can give you guys that a feeling about the field in general, and then what the Wayne State faculty are working on. So that was the sort of give you a brief idea about what is this seminar series. And today, like Professor Swibert just introduced, that I was spending some time to give you some background about edge computing, edge intelligence, and how this right now has been actively applied to the CAV space. I was just using CAV, which stands for Connected and Autonomous Vehicle space. So here is, for those of you who are first time, attending this talk, I noticed that several of you may come from, internationals. So I want to give you a little bit of facts about the Wayne State so that you know that, where we are and how's our college and the computer science, in general. So here is Wayne State. Many students, when I recall when I give a talk outside, they always ask me, Wayne State, which state is Wayne? Among 51 states in the U.S., there's no such a state called this name. So we actually is located in Detroit, Michigan. So if you every time when you travel to Detroit Metro Airport, you're gonna see this slogan there. Detroit was considered as America's greatest actually comeback city. That had been a lot of good news, positive news in the last decade, because you might heard about 10 years ago that Detroit has been bankrupted, filed the bankruptcy, but in the last 10 years has been doing great. So this is sort of a view from our computer science office. It's not exactly, but if you're using the latest iPhone 12, if you zoom at about 5x, I did this test, earlier this week, about 5x zoom in. This is exactly the view from my office, and Dr. Sweeberg is my neighbor. So this is what we are seeing there. So sort of give you an idea that this is, today's Detroit, that we, in the middle of that, the tallest building is the headquarters of General Motors. And then you have this Detroit Lions, Detroit Tigers. On the right side, we couldn't see is the latest Little Caesars arena for Detroit Pistons and Detroit Red Wings. So Detroit actually is a very interesting city that have one of the few cities in the United States have 4 major sports teams here. And then across that river is Canada. So it's kind of a, between the boundary of US and Canada. So that will give you a location-wise. And many of you heard about that, Detroit is also we call the Motor City. Basically, it's the headquarters of pretty much, it's called the capital of the automotive industry. So Wayne State, in terms of research funding, is like top 50 public universities. And then in particular, we have 13 colleges, among them School of Medicine, College of Nursing, College of Engineering are pretty strong, in terms of national ranks. For those from China, because there is one of the very famous Canadian doctor was in China about 60 or 70 years ago. So I have to speak Chinese so you know who I'm talking about. Dr. Bai Chuan. Dr. Bai Chuan was a former Wayne State faculty before he went to China. So that was happening about 70 years ago. So in China, almost every single family knows that Dr. Bai. So he was in Canada. You see the picture I showed. He got his degree there, and then he started working at the Wayne State Medical School. So that just gives you an idea. And then we zoom into the computer science department. We have 5, NSF career winners, and right now I think the number is 23, but it might be have a little bit of fluctuation depending on some of the faculty recently joined us. That was just to give you an idea about where we are. So this picture I took it on the ground so that you see just now that the view is from my office here is the 14th floor. And now this view is on the ground to look at where we are. Is our building next. I think it was about 100 years, 1960-year-old right now. It's still functioning pretty good. So that is where if you join us in computer science, then you most likely will be in this tall building. A very I wouldn't say old, but it's a sort of a classical, beautiful. Granite made the building. So that was a quick view about that, the Wayne State. And then College of Engineering, computer science is part of College of Engineering, is one of the 8 departments here. And this picture shows that College of Engineering, where Dean's office is located. And there's a new branch that's called, what do we call Engineering Development Center, was relatively new, and several modern labs was hosted in that extension. So roughly give you an idea about Wayne State College of Engineering. So we totally have about 30 alumni, in the world, and then I was, we have about 130 faculty members in the 8 departments, and that was roughly give you an idea that, as you can see, a little bit, like sorry for the bachelor, sphere here, so that let's say 3/4 of them are undergraduate students, and then we have another quarter of the students are masters and PhDs. So we totally College of Engineering have about 300 PhD students, and we are actually in the process is trying to bolster this number to about 400, so that that was our goal here to grow that for the College of Engineering. Let me see that. Okay, so here is where the major departments, the 8 departments. We do have one of the earliest in the nation, biomedical engineering. So he's looking for pretty advanced technologies. We're funded by the NIH, National Institute of Health, and then we have chemical material engineering, civil and environmental engineering, looking for the civil transportation. The reason I mentioned them a little bit is because this were related to what my talk today. Most of this, for example, in the chemical, basically we have faculty looking for the newest material for the future vehicles, for example. In the civil and environmental engineering, we have a dedicated group on the transportation, looking for the smart infrastructure. How do they support, the next generation of mobility and etc. In computer science, so we have faculty basically in the AI, and then we also have faculty in the computer, system networking, real-time system, which are pretty strong here. In particular, I want to point out that is if you based on the CS rankings, which is very popular in computer science, how to determine people use as a metric to decide that the ranking of the departments. So real-time and embedded system, Wayne State Computer Science is ranked right now is the 7th nationwide. So to give you a sort of a taste of this, UC Berkeley is 8th. So we are 7th. That basically shows that we are very strong in terms of the real-time embedded system. That's also highly related to that, the vehicle, because of the vehicle have a lot of real-time requirements. We have electrical and computer engineering, which is one of the oldest department here. We have a lot of famous alumni, graduate from ECE department. That to give you a taste, because recently I just have an email communication with him, the provost of Hong Kong University of Science and Technology, Dr. Nino Ni, graduated from ECE department in 1977. So that was, I just to show one example, because I do see quite a few Chinese. Some of you guys might be his great grand academic son or daughter of him, because I noticed that some of you has this relationship with him. He actually graduated from us in 1977. So that was even, I was like a baby at that time. So, and then we have industry system engineering. I was going to spend time to talk more individually, mechanical engineering, etc. The last thing I want to mention is we do have an engineering technology division. Right now have a very strong collaboration with China. So we have those so-called 4+0 program in Ningbo. So some of the students that are actually studying there, and then we sending our faculty members go there to teach, and eventually that they can get a Wayne State degree there. So that was through our engineering technology division to do this type of collaborations. Okay, all right. So that was sort of an idea, give you a broader view about the Wayne State. And then I will go to, here is the outline for today's talk. So I'm trying to make this a little bit interactive. So if you have any questions during this talk, please go feel free to ask. So one of my PhD students, Yongtao, you are helping me to admit more people in the waiting room. Okay. so that I don't want to be interrupted to admit them into this the meeting room. So what I will do is, like Laura mentioned, that I starting talking about edge computing, and probably starting 2014. At that time, while I was at the National Science Foundation as a program director. So I want to share with you that there is an interesting journey here. As of today, you might think about everybody, that feel like edge computing is already a field. I do see many people putting edge computing on their resume, said this is one of their research interests. But I want to share with you that not everything starting with this, just like a cloud computing. If you are working on cloud computing in the year 2004, 2005, probably nobody is buying you. What are you talking about? What is cloud computing, etc. So I think it's very important for us today. If your advisor asks you to work in this field, don't just take it for granted. Edge computing is very important. I'm going to work on it. So it's good time. Particularly, I encourage the PhD students to think about that. Why this something is here? So maybe down the road, in the future, when you become a faculty, when you become, a leadership in a leadership position in industry and somewhere, so you should get the sense about what technology will be important, down the road, because that's the key to become a research scientist here, right? So it's not really that exactly the topic you are working on. It's the way, how can you get a sense about what's next? If you can be able to define something for other people to work on, that would be fantastic. I normally, this is what I told my PhD students, go back to 10 years, nobody will remember what you did in your PhD. However, they might be care about that, the thing you getting the sense about looking forward, what's next thing. So that's the first part of this talk. I want to share with you some of these journeys that where I went through. And then we will talk about, edge intelligence. The idea is, it's also pretty common today. It's pretty natural. What does, that people putting the intelligence on the edge, some, just called edge AI and many other names. But what is this really about? So I want to talk to you that about this, that through some nuts and bolts approach, so give you a feeling about what is edge intelligence. And then the last thing is we will spend some time here on how edge computing, edge intelligence has been applied, to CAVs. And this is just the beginning. It is a new area. Even myself, we started working on CAV space probably 3.5 years ago. Yeah, but we have made a very good progress in the last few years. And then I will share with you some of these exciting things. Okay, so let me see. So before we talk about that, so now let's, I wouldn't say close your eyes, but you can imagine that, where are we today from a user perspective? Think about that user. So if you are senior enough, you might remember that you can even think more. What are you doing? 10 years ago or even 15 years ago. That was something. Think about that. Okay, for some of the young students, 15 years ago, you might like in elementary school. So that's you can still think about that. How do you use the technology? So basically, 15 years ago, what happened is there's a big event happening. Is there's a company called Lenovo. Some of you probably know that it's the largest PC maker in the world today. In China, that they purchased the IBM, the PC, the whole PC division. So what does that mean is that's a significant event happening. You might be wondering why did IBM sell their PC? So if you think about that, today everybody using acronym PC, but have you thought about what does PC really stands for? And who come out of this definition? So PC means personal computer. So this concept was introduced by IBM in 1980s. So IBM played a significant role in the history of computer science. So pretty much everything in the last 75 years, IBM is always in the position to make this significant shift. For example, before 1980, when people are talking about computer, there was no computer science. Our computer science was founded in 1970, around that time. Everybody, when you're talking about computer science and a computer, people refer to IBM 360. That is IBM's machine. And then in 1980s, IBM introduced this PC. So they view like a personal computer will be a big thing. You're not going to go to a mainframe. You go to every single people going to have a individual computer to working with. So that was IBM's concept. So after 25 years, IBM already viewed that the individual PC era is still there, but there is not as big as a new thing going to come, which is called cloud computing. So the idea is they already view that. They found that individually make this kind of individual computer itself, you're not going to be make a lot of business there. So what happened is the way we are using computer is changing significantly in the cloud computing era. Like today, that when we give this talk, particularly during the pandemic, can you imagine that if this pandemic was happening like 15 years ago, what's going to happen? How can we adapt to this online teaching? And it will be, I would say, it's much worse than what we have today. But because of this cloud computing technology here, that even during the pandemic, the kids, they can also go to some of them, probably because of have limited access to the resources. However, I would say, a lot of people, including Wayne State students, so we have access to this kind of online teaching, right? So software became a service is changing significantly. And like Gmail, Amazon, I still remember those old days when we have a computer, if you're getting a new computer, it's quite troublesome because you need to, in addition to reinstall all these softwares, you also need to copy all this data and that's to a drive and etc. Especially we all download our emails to our local drive. But today, how many of you actually downloading your emails to a local drive? So I can share with you that if I getting a new computer with me, less than 2 hours, everything just like a previous one. You don't need to do too much things. Basically it's the several applications is already pre-installed, and then everything is in the cloud, right? So your friends, your contacts, everything is on LinkedIn, Facebook, Instagram, right? So that was significantly changed the way we are using this computer. Even for the scientific research today, people used to buy a cluster. When we hire new faculty member, they normally ask in startup, okay, buy hardware, etc. But today, if you ask your chair to say, okay, I want to buy a new hardware, they were starting to scratch the head. Are you sure? Why do you need to buy this? This is very expensive. How about you getting, 1/3 of the money? You go to Amazon, Google, just buy some cloud service. They have the latest computer hardware for you to run experiments. So those are how powerful cloud computing has brought to us. So now, let's think a little bit about that. As a computer scientist, when we talk about, we're not just a user of cloud computing. We need to think about where our innovation gonna be, right? In the cloud computing era, what is the definition of a computer? So those are the something we need to think about. In 2008, that David Patterson, so he's a former professor of Stanford University and also the AC Turing Award winner 2 years ago. So he published a paper called Data Center is the Computer. So basically people realize that if you claim you are working in computer science, you should work on data center, because in the cloud computing era, except those, that there's everything is going to be stored in the cloud, stored in the data center. So where is the cloud? It basically is a huge data center behind the scene here. So most of the research in that time, from after 2005, is working on data center. The earlier you are in that area, actually, the earlier you will be a pioneer in the cloud computing. That was what the people are talking about. Today, you may still see a lot of people working in the data center, right? That's because of this this nature. In addition to the data center, and then it's the edge devices, because everything is just sitting behind the, computing power is in the data center, and then on the edge. So we're going to see more and more Internet of Things. Mobile devices is fast growing, but the number of desktops is starting to drop. That was the ways. On the other hand, a lot of people after 2005 is starting working on moving to IoT. Today you can easily see some of the professors are going to tell you that my research area is on IoT, right? This is very common. So, but I can tell you that if we zoom, dial back to 2005, if you tell somebody said IoT, nobody even understand what are you talking about. And cloud computing, what is cloud computing? Nothing new in the cloud computing. They even challenge you that cloud computing, what's the difference, between this and the grid computing, etc. So this is a very common for every single that I believe in other disciplines as well, although I didn't do a research on that. But I have a very good feeling about when we starting promote edge computing, because at the beginning, majority of people is challenging you that what is this? Why you need this? And what's the killer application? They always ask this. Those are all legitimate questions. So if you want to argue on some interesting, direction, you need to be prepared for that. At least first you need to believe yourself, right? Okay, sorry, this was like click the wrong button. Okay, now, so if you're thinking about that, we go a little bit faster, forwarding from the 05 to 15 in these 10 years. So we caught that the data infrastructure 1.0 at that time, the key features here is you're collecting a lot of data, social media, web, video, audio, and then you're sending all of them to the cloud as shown in this figure, and then you process them, in the cloud. So one of the famous paper, which I think the reason why Jeff Dean is getting this, has made significant contributions, receive a lot of almost all the awards in the computer science field, and also being elected to the National Academy of Engineering, is one of the significant contribution is this paper called MapReduce, published in our computer system top conference OSTI in 2004. So if you think about that, okay, cloud is here, beautiful. Now, next thing is, how can I write a program for that, right? So you all of a sudden you deal with 1 million processors. Have you, any of you trying to write a program for 1 million processors before? Well, all of a sudden you are dealing with 1 byte of data, not even, let's say, petabytes. So even terabytes of data, you probably have to writing a program to deal with that, right? Even today, 2021. So the big challenge here is without a good programming model here, nobody can benefit from cloud computing because you don't know how to write a code here. So that's where MapReduce jumping in. MapReduce have getting proposed, although it looks like it's a very simple today, but it's a significant. With MapReduce, and then Yahoo and take the leader, come out this Hadoop. Some of you probably remember that. Have an open source implementation of MapReduce, and then this opens a new era of cloud computing. People are starting, hey, we can easily download the open source and deploy it here, and at least we don't have 1 million processors, but we can have like 100 processors. We can easily deploy them to run the program here. So that is the key here for the success of cloud computing. Why I'm mentioning this, because you need to look back on this history, what happened, why is success, and then why some new idea is not flying. And so there are some reasons behind this. So that's, if you see the timeline here, OSTI paper 2004, which means at that time, Google Insight already come out with this implementation to do this data processing, which laid the foundation for today's cloud computing. So that was the idea, when the public became aware of this. And then, I'm using 3 V's here to show that how big, the characteristics of the data. You might argue that, my advisor told me it's 5 V's, 7 V's. That doesn't matter. That's not the point here. The point here is just give you a sense about, the size of the data, and then the speed of change of this data, near real time, not really real time, right? And then in the infrastructure, if you are doing research in this, another issue is goes to reliability and availability. So you guys probably know that even today, yesterday, I just read the news. There are about 90 seconds. There is a glitch in the Akamai. For those of you probably, if you don't know Akamai, Akamai was the earliest edge computing edge computing company was 1998. It's a content delivery network company. So yesterday, because of Akamai is one of the misconfiguration that many major websites such as Delta Airline, and this was out of service for a few minutes. So that is related to the availability because you now rely on the whole thing is on the cloud, which is you have no idea about what's going to happen. So this is the beauty and also the disaster of the distributed system. Some days maybe that we used to say in the far away, in Oregon, probably because of fire, one of the trees falling down. That's impact you. Your water in your home in Michigan probably stopped. You might wonder what's the relationship between these two? Well, possible because that electricity might be contribute related to somewhere coming to your electricity, and electricity eventually impact of your water distribution system, etc. So similarly here, in this digital infrastructure, it is very important that, this reliability, availability issues that you have to deal with. So a lot of effort has been putting on into a single data center. And the other thing is about the sustainability because data center consume a lot of energies. So people even come out with a new metric called the PUE, power utilization efficiency. So they use this, put in a short is, this data center consume this amount of energy, but among this energy, how much is was used on the IT to do useful computing things. If you are not managing very well, you probably will be half of the energy was spending on the cooling system, right? Because the data center itself is cost a lot of energy here. Because of this reason, so the PUE was really a very good indicator for how efficiency of the data center. So if you are talking to some data center, you can easily ask them. So give you a rough idea, PUE equal to 1 means you are 100% using them efficiently. That will be the ideal case. Today, in many of the data centers of the world, on average, this number is 2. That means you're spending quite a lot of energy actually is wasted, to do something else. Yeah, but in 2015, when we, at NSF, we organized a workshop at Stanford University. We that called NSF Workshop on Sustainable Data Centers. So we invited the architecture from Google and Facebook come here give the talk. At that time, their data center, the PUE number goes to 1.03, 1.05. So that is, we consider is very efficient. So if you are interested in working in this area, you are more than welcome to go to this link and then to take a click this report that I have to give credit to the two co-chairs, Thomas Winish from University of Michigan, Prashant Shnoy from University of Massachusetts. So we invited them, these two, professors to running the workshop. Okay, that's about the data infrastructure 1.0. So now 2015 is opens. So when I was at NSF, we starting look at, okay, cloud computing has been there 10 years. What's the next thing? So we starting evaluate at that time. So some people were asking that, well, edge computing, this term is not new. We completely agree. As I mentioned, Akamai, and perfectly yesterday there is a glitch at Akamai. So give me an early chance to mention their name. So if you're looking for Akamai was the biggest company in terms of content delivery network. The idea that was in 2000. So the idea is how do you distribute all this web content to the client as early as possible? So the interesting thing is CDN is the earliest edge computing concept, but their focus on is deliver this static content. So and then cloud computing jump in. So nobody even moving further talking about edge computing. However, 15 years later, what happened is the things changing significantly. If you recall, I mentioned earlier, where are we today is we are so much rely on cloud computing today, right? So imagine that if I'm giving a talk right now, you have like 10 seconds, even 5 seconds delay. So what's your feeling? So you will feel very strange because you feel like, for this particular voice kind of communication, you have the maximum latency you can bear probably is a 500 milliseconds, is a half second. That is okay. After longer than that, you will see, voice and the image are going to be asynchronized. They're not synchronized. In that case, you will study very, fuzzy, and then gradually you are lost interest to attending these meetings. That's exactly one of the biggest motivation for edge computing is because of the cloud providers push, because they want to deliver their services globally anywhere in this on the planet. Maybe sooner go to on the outside, Mars somewhere. But right now they want to say anywhere less than 30 milliseconds. How do they do that? Edge computing is the only solution because this way they can improve the availability. For example, you have if there's something wrong, only that small portion has been can be isolated. The rest of the world is still performing good. The other thing is about bandwidth. Cloud is not free. So when you talk about using these cloud services, for example, Alexa and etc. On this, eventually, this a lot of communication happens between you as an end user to the cloud provider. So there is a lot of bandwidth requirements here. Let me pick an example as a vehicle as an example, because when we we're working with a project with Toyota, we were asked that Toyota is very interested in a topic even the one company alone have more than 100 million vehicles in the world. If Toyota want to know what's going on with all of these vehicles, although owned by you, but if you have a problem, you still call them, right? Go to the dealership. So they will want to monitoring the behavior of all these vehicles, including their brake, their engine status, and etc. So they would like to collecting all this data. Now, collecting this data, each vehicle every 5 seconds, let's say collecting 300 parameters. And this data that will be, think about is 100 million vehicles we're talking about. That's going to be consuming a huge amount, generate a huge amount of data. And then, using communication, using the bandwidth to sending back to their data center or server. So now the question is, who's going to pay for this bandwidth? Have you thought about asking end users, you and I, we buy a vehicle, then we pay them. We pay extra bandwidth just for them to collecting data. No, that's not going to happen. You don't like that. So what they will do? So obviously they don't want to pay that either, right? So if they deploy a SIM card on your vehicle and then they pay, let's say $50 a month just for the collecting data, that will be a huge extra cost for them. 50, you can do a little bit of math here, $50 a month, and then 600 a year for one vehicle, and then you have 100 million vehicle. That is pretty much, that's even bigger than their whole revenue every year. So that's the reason why for them, as more and more industry starting pull on to just starting using cloud, using this, they need save bandwidth. This for them is not just they want, it's not like a side work for them. This is their reality. They have to deal with this. As you probably, if you pay attention to the CES, in Las Vegas, the last few years, you heard the CEO of Ford Motor Company said Ford is not a automotive company. Ford is a technology company. The same thing echoed by the CEO of Toyota. Toyota also said we are not a auto company anymore. So Toyota is a technology innovation company. So what does that mean? You probably can getting a sense about that. So they're all going to be more and more moving to this part because save bandwidth is another huge benefit here. But the reason I'm spending a little bit more time here is because many of the papers we have seen published so far always dealing with latency. But I want to remind the people that bandwidth even more important, not necessarily at least equal important of the latency that brought by the edge computing itself. Because if you go to a large scale, you will see that the bandwidth saving is a huge impact economically that to the society. So this is we call a push from the cloud provider. So that's the reason today Microsoft, Amazon, Google, they all being very active in the edge computing. They continuously provide their edge computing services and either equipment and product. So I want to point out that in July 2017, Satya Nadella, the CEO of Microsoft, he defined Microsoft as it's not a cloud provider, it's not a office automation company, it's an intelligent edge company. So that's even happening in 2017. So that's just give you idea that about things is many people believe that the second reason is the reason why edge computing. But the reason I put the cloud here earlier is that's not the real, the only reason here. For the second reason, as I guess people will be knowing this quite straightforward because Internet of Things became popular. You deploy a lot of sensors, collecting data from Boeing, from autonomous vehicle, right? Then you have the resource constraints. But there is one thing we need to make sure that is security privacy concern from this data collection is another big motivation for the edge computing. For example, at your home, Alexa, Amazon Alexa, or maybe Baidu, Xiaoyu, they call the doors, different type of company, they collecting a lot of data of your home. So in that cases, as an owner, you care about this. You don't want your daily operations that at home that the privacy security concerns has been you don't upload it to somewhere, right? So you really want to the data just stay as is. Similarly to the driving the vehicle, I mentioned earlier, your driving behavior, you probably don't want that all this data being collected, either because it's not necessary or it's probably don't need that. So for those of you who are using, I'm not sure other insurance company, I'm using AAA insurance. So recently, AAA has deployed this service that you can install an app, allow them to watching your driving behavior, and then your insurance is going to be reduced significantly. So the idea is exactly that what I'm talking about here is this app using the sensors, on your smartphone, and then they using machine learning technology to derive your driver behavior. For example, one day when my daughter was driving, and then she is still learning the driver license. In one of the intersections, if she hits the brake, too rush, and then that app actually can do this. They know that, and then they will tell you that the reason for this trip your score is following is because of the following actions. That they actually can exactly tell you that where did you just now, trying to rush and has a potential risk to getting an accident. So if you're looking for this this application today is already running as a daily operation today on millions of these users, the phones now. But as you can see that this privacy concern is a big deal, right? So that for learning for kids to learn how to drive, I think I like it because this way we can know that was something wrong and etc. But after that, you and I probably don't want them to continue to look at this. At least you probably want to say that you can get this number, but don't share with anybody else, right? So that was another reason. Edge computing is a perfect place for you to do. IBM coined as called real-time context computing. So you do the computing, get the results, give me a score, and then delete all this data. Please don't download this data. Save the bandwidth as well, and then that you can move on to support this. So that was the idea that we're edge computing when we at the 2015 time frame that we think about why edge computing era is going to come in. So that's sort of give you an idea. And then the following figures you probably see many times. You're talking about even last year, 60% of the data will be generated as the edge. So that's is sort of a validation whether we observe, whether we are thinking about it. At that time we sort of guess 5 years ago. So even further, Gartner predicted that by 2025, like another 5 years, 75% of the data will be sitting located outside the data center. That's very different from 2005, 2015, because the majority of the data is located in the data center. So that will be, a big, shift. If you see that where our data located, it has a big shift from the cloud to this. So this figure shows come from, Dell. They shared with us, on terms of vehicles. So why we are interested in working on the vehicles is because that by, this time that 5 years from now, maybe even less than that, 17% of the global data generated will be actually, from connected and autonomous driving vehicles. So that is a big impact, and that's why we are very interested to looking for apply edge to this. It's a huge impact, a potential impact here. So roughly, depending on the different application areas, and then you can see that today edge computing have a relatively like a 3-tier architecture here. You're using IoT to collecting data, and then depending on edge itself is not a fixed device. It's kind of a spectrum what you are talking about. Depending on what you are talking about, that you can, for example, if you have a drones flying with next to a vehicle, that vehicle is an edge. However, if you have a vehicle itself is IoT, then the cellular tower roadside unit will be the edge devices. It purely depends on the scenario what you are doing here. But just roughly give you an idea that the cloud is still there, and then edge is the middle layer that provide extra services connected with IoT devices using different communication mechanisms here. So this was a paper we published in 2016 that I sort of give a definition of what is the edge computing. And then basically we're talking about the edge is not just, is sitting there for two-way traffic. One is for the upstream, the IoT device, you collecting data, we do the data processing. Also from the cloud, service you come here, we can also do something to customize that for the specific users. So that was give you another share, or what kind of things you can do there. So now with the edge computing, we imagine that the digital infrastructure is going to move into 2.0. That is what happening is, as if you remember the previous red part, now it goes like this. So the volume of this data, it goes to the ZP level because it goes to 1 million times of what we have 10 years ago. And then the velocity of this data is real time. For example, you're dealing with autonomous driving, you have to make this, decisions within 30, within a certain amount of time. It depends on, for example, if you're driving, running into a human, in front of you, you have to make a decision immediately, right? In a real time fashion. So as you can see that now, the first question similarly go back to that is, we talk about edge computing, and then how can we write a program on this? Now go back to this, to this question, programmability, because you can't just propose ideas that, yes, I agree that we need to using edge computing, but how can I write a code for the edge computing? So that was today, we don't really have one, but Professor Satya from CMU is one of the pioneers in this area. He proposed an idea called the cloudlet. That's even quite earlier. But at that time when he proposed, the cloud is still popular, so not many people pick up this. But right now there's a lot of people thinking about using this cloudlet, and then our group have doing something called the firework programming model. I wasn't going to be spending more time talking about specific things, but the idea is you sending a request, and then the request will be like a firework distributed to the data, where the data stored, and then do the processing there, and eventually collecting data back. And nowadays, a function as a service is another one, a potential way to do the programming. But as even as today, yesterday I was talking to the chair of Arduino. Arduino is an open source that edge computing framework, Linux and the Linux Foundation. They're also talking about. So I think there's a lot of companies form a consortium trying to come out with ideas. How do we deploy the things and etc. So those are still a very active research topic. But as now you understanding why this is important, because if we community keeping talking edge computing is important, and then people don't know how to writing a code, deploy their services, this area will be dying, no doubt. So you have to come out with the tools. It is our responsibility to come out with open source tools so that other people can easily deploy it. So I think Amazon Lambda, Microsoft, a lot of people is pushing in this area, which is great. And then continuously with the two other topics. One is the health management. And when I say health, is infrastructure health. Reliability, availability. Now you still need to focus not just on the data center alone, because you have to deal with edge server, some people call it edge cloud, and etc. So if there is something wrong there, you have to deal with that. So that was related to this health part. The last thing is about, again, sustainability, because So as you rely more and more onto this edge computing, this type of infrastructure, you have to think about even your data center is very energy efficient, but it doesn't mean your whole thing is energy efficient. But let me give you an example. In the vehicle space, now people all talking about we gotta go to electrical vehicle. By 2035, then we will be carbon zero. Do you believe that? When I say, do you believe that is, have you thought about that today? Starting, many companies, OEMs already make the announcement that their future vehicles, all of them will be connected. And they might be have the more function as autonomous driving, at least ADAS. So are those functions free? So these functions, every single service you are running on a vehicle, for example, you dying something, you make a phone call, you run entertainment. For example, you are watching if you are using Netflix, watching a streaming on your vehicle. That means this service itself has consumed a lot of energy on the infrastructure. You just don't know, you didn't aware of that because the vehicle is not alone anymore. Vehicle is not like you putting an electrical battery and then that this is a hue of the vehicle. The vehicle is the service you are running here is going to be invoke a lot of other computing and communication happening at the edge, at the roadside unit, at the cloud. So those are also is the energy consumption coming from you, but you just didn't realize that. So this is something we are really arguing that for all these companies, for example, Toyota, GM, these companies, if you want to claim that your vehicle is, zero carbon free, you have to take this digital infrastructure into consideration because this cost is going to be huge. To give you a sense of that, according to a study from Tesla, for fully autonomous driving, that vehicle today, 1/3 of their battery power will be used on the computing. So if you want to have a fully autonomous driving vehicle driving on the road safely, reliably, 1/3 of your battery will be spending on the computing alone. So that was today's, that was roughly give you an idea about that. If you're driving in the big cities, it might probably consume more. On the highway, is less because the computing requirement is less. So this is something we want to share with you that is, edge computing is not free here. When they brought this in, they also introduced a lot of these potential accessibility issues. So if you are interested in this issue, in 2016, Professor Mo Chang right now is the Dean of Purdue University. He was a professor at Princeton. He and I co-chaired the NSF workshop on grand challenges in edge computing. Even today, I believe that the report that we finished 5 years ago, it still make a lot of sense. There is a lot of challenges we identify haven't been addressed. So if you are interested in, you can go to this website. Actually, it's on Wayne State website. Download the report and then trying to find the areas working on that. So that was give you an idea about digital infrastructure 2.0. So here I'm using this figure to show you, give you a sense about how this service is related to the infrastructure, which normally as a user, you don't realize that. So here is when I give a talk at Facebook. So I'm using Facebook as an example. They have many data centers. Those are the real, by the way. They actually have much more than that. Global size, and then they have edge cloud deployed somewhere. And then imagine that you are right now is here. When you access one of their Instagram, for example, share a video or using Messenger, starting Facebook, talking, video conference, you will go through this way. Maybe during the day, Tennessee have a very good sunshine, the energy efficient, so you can go there. But then when you became travel at home during the night, you realize that wow, it's already dark here. But Singapore, is sunshine there. All of this is solar powered energy, etc. So you actually can go that way to get into the services. So although I said it's from what I presented in the last 10 seconds, is very simple, right? But this is a huge challenge here. How do you know that? Where this energy source come from, right? At any particular time. So if you are interested in this, one of my PhD students, and then working with another professor in the civil engineer, Professor Carol Miller, we actually come out approach. I think Professor Kenshin mentioned this also last time. He's also a co-author of this. So we come out machine learning tools that can tell you that at any particular time that where your energy source is coming from, either coming from maybe from this traditional charcoal based, or maybe it's coming from the hydrogen, this type of. So that was an interesting, that was the foundation. You need to know where they come from, and then you can start into the routing, on this internet. So this will be completely change the way how the internet is doing routing today, because when the TCP/IP was designed, nobody is considered sustainability here. But those are the potential, very interesting ways for the people to look at this. So speaking of this, I just want to see, because I noticed there are several students come from China, so that I want to share with you that the idea is, if you understand, most of you, if you can hear, you understand English, but sometimes you still prefer using your mother language reading stuff. So the first article we wrote on the IoT edge computing, that has been cited 35,000, 3,500 times. And then, sorry, for those of you who don't understand Chinese, it's fine. But this was the paper, the first paper in China is on edge computing, was written in the earlier 2017. And then this paper was last year, has been downloaded 12,000 times in China. And then that has been one of the 100 papers received the national award for this. So that for the impact of what we have done. And then a couple of colleagues in China working with me, we wrote this, the first book on the edge computing that earlier this year has come out the second edition of this book. So for those of you understanding Chinese, so you can download them, and then you can buy them. Actually, it's very cheaper. The reason publishing in Chinese is because it's cheaper, way cheaper, less than $10. You can get this book. And also on the proceedings of IEEE, that they invited me to organize this special issue. I would say by August 2019, anything before that, most of this, the papers has been covered by this special issue. So if you want to, if you're new students working in this area, so you are encouraged to go to this website, or go to this, go to the proceedings of IEEE and download this 13 articles we have assembled here. So that this was in the volume 107, 100 years. There are more than 100 years, number 8. So you can sort of getting an idea on this. And then last year, well, not last year, 2 years ago, when the first journal in China has been trying to celebrate the 60 years, the first computer science journal, and then they invited me writing another article on this edge computing. What's the future on that? So this article, I think right now it has been downloaded 7,000 times there. So if you are working on this, prefer reading Chinese, I highly recommend you to reading these two the articles, so you can start with it. For the other English writers, so we have all these papers available on our website, so you can always download them to look at this. So now I want to talk a little bit about that why edge computing is important. And when I give a talk, I have been talking publicly speaking on edge computing more than 50 times. University companies, most of these the companies I have a chance to visit them and talk with them. So you can see that if you want to propose a technology, a new concept here, that first give some tangible things for the people to play. For example, I keep mentioning that the programmability is an issue. There's another thing is, how about the industry people? Are they buying this idea? So this figure shows you that it's a wonderful idea that why edge computing is so important. Pretty much you can see that cloud computing providers, we already know that. Now look at the hardware providers, Intel, AMD, ARM. So for those companies, if you're looking for their business, most of them goes to in the cloud computing era, making chips, for the data center. So what's the next thing for them? Obviously is edge, because who can, edge is going to need a lot of CPUs, GPUs, and etc. Right? So that's why all of them has become a big player here. And then you look at the service providers, such as the CDN. So Akamai, Cloudflare is one of these, the companies. I think the stock was increased significantly during this pandemic. Those are CDNs that they also want to deliver their services fast, reliable. So they'll also be all the way to move into this. And then if you go to the communication, So, many carriers, for example, AT&T will say that their future will be 5G plus edge. That is where in China Mobile, China Unicom, and then you go to, Europe, Telefonica, Vodafone, they all buy in, edge computing is the future. So as you can see that why this telecom think edge is important. If you're looking for their own history of the industry, you might be seeing that, the issue here is telecom always being treated like a pipeline, like a pipe, communication pipe, right? So they also need to think about how do they make new ways, for their business. So if you edge is perfect for them because they can add more function there, and then they can charge more, on that. Otherwise, if they just provide the bandwidth, and then they will getting more and more challenges. For example, one example to show you guys. Today, how many of you are still using traditional SMS? I guess you still have some people, but not many, right? Since Apple introduces this FaceTime, right, and then you have very many other social medias, WhatsApp, and then you have WeChat and etc. Nobody even care about what's your phone number now. So I was usually joke, when I travel on that, when I meet many of my friends, is I don't even know their smartphone phone number because not because of the in US side, many people treat this as a privacy. But if you go to China, the way is different. It's not the privacy issue. It's because you don't need to know their smartphone number. Nobody is making phone calls these days. Why? Because it's all being replaced by other service. So this is a very big pain point for the communication carrier because they used to make money, charge, make the business is from the phone calls. All of a sudden, nobody is talking over the phone. Well, they still use a phone, but they're not using their traditional phone calls. So that's why they need edge computing to add, to bring back their business. So that's just to give you an idea about that. And then consortiums communities, as you can see that AECC, Toyota took the lead, created this automotive edge computing consortium. And then in China also created this edge ECC, edge computing consortium, more for the smart manufacturer. I think I don't know have the latest number, but last year already have more than 500 companies is part of that consortium looking for the edge computing to change their way to for the next generation of the smart manufacturer. So if you've been convinced that wow, pretty much all these companies are on this side, so you sort of getting an idea that this is something a big wave is coming, right? So that was today. When I talk about this, you feel like, yes, yeah, those are people already working on this. But imagine that all of these things just happened in the last 5 years. I still remember, you guys probably see, in China, WeChat parent company, Tencent. I still remember the first time when I talked to one of the big management there is they said, well, we are still evaluating, edge computing, see how Tencent can benefit from this and that. But today, if you talk to them, this is not on their agenda. Sorry, I didn't shouldn't use an agenda. So it's not out of question there. So that obviously we are a big player of edge computing. That was like 3 years changing. That's changing the landscape. So that was to give you an idea. And then many people asking that, hey, what are the killer applications? So my answer to this is you don't need to asking what are the killer applications today because it's already there. For example, live video analytics for public safety, connected autonomous vehicle, and smart manufacturing, smart homes. Those are already have a product that has been penetrated all over the thousands and the thousands and the tens of thousands of homes. You have using Alexa, you are using edge computing, you just didn't realize that. So those are the things has been deployed there. And then latest thing here is on the smart grid, smart connected health is also picking up. There are languages this, for example, during this pandemic, edge computing will be perfect to do a lot of this COVID, related analysis and etc. That a couple of friends, I know that they are using this, including ourselves, have NSF funding using this to do the analysis, etc. So just to give you an idea. So I spent quite a long time to share with you about why is edge computing, because I feel this is more important than the research itself. The research itself, I can quickly go through that, and then you can go to our website, download the papers, and reading them. But it is the most important thing is why this is important. That's the key here because for the research here. So now next I want to share with you is when everybody talking about edge intelligence today, have we thought about why edge intelligence is there? Now, when we talk about intelligence, we need to think about that, AI, because, artificial intelligence. So why is AI hot? And some of you probably know that, but I just want to go quickly here. There are three reasons behind this. The one, AI has been hot for many, many. Some people think that this is already the third wave of AI, right? So that as an indicator is SEM Turing Award last year given to the three big names in the AI field. That's because of that. You can see AI is hot. This round of hot is there also have a reason here. One, computing power is becoming cheaper. You have access to this computing power. Imagine that you without this super fast computer and all these GPUs and etc. You can't really do the learning. Take you a month to do training a model, so you are not going to be using this. Second is data. Where does this data come from, right? We have generated a huge amount of data that is allow you to train them. For example, I try to using on my iPhone to do this, real-time translator. iPhone is great. No matter what language you are speaking, most of them they're supporting. I can only speak two languages, sorry. So that I try to speak Chinese, they translate to English very nicely in real time. I believe these are all, down on the phone today. Why they can do this so smart? It's because they have collected tons of this data, allowing them to train these models. And then the third thing is on the left corner is computer science. I have to say that, I'm very happy to be a computer scientist. Is our philosophy is very simple from the beginning is everything open source. So this is very different from other disciplines. Other disciplines, normally they don't do open source sharing. Every software is very expensive. It's just a different way to deal business. Computer science is very open. Everything is open. You download, you play with it, and then we believe that this way you make things even better. And then you can still make money, out of this. Because the philosophy here is somebody use your stuff, then they're willing to pay you money. It's not like, okay, that was all this open source available, make it much easier to getting AI. So I could joke here is, I recently have a high school student working with me, 10th grade. She just spending 2 weeks. Now she can do a face recognition, using one of our, smart robot that can moving around at home. Imagine this is a 10th grade. Although she is very smart, but at the same time, you need to realize that all these things, you download the software, configure it, make a basic movement. It's very simple. So that's why that today, when we talk about the machine learning, 99% of, many people can spend like maybe, 2 weeks, they can claim that they are one of the experts in this area now. So it's all benefited from this. Now, next, sorry, we go. Then why, AI has been hot for a while, but then why all of a sudden starting 2019, the edge intelligence became popular? So because AI has been hot for a while, then the people is getting tired of them, right? That's on the psychologically. But at the same time, you will see that edge side, we already mentioned, 75% of the data will be on the edge. Edge side data need AI to fully unlock its potential, right? You just collecting data without any actionable stuff. That's meaningless. For example, I mentioned Toyota, Daimler, this company, they want to collecting the data to monitoring the behavior of their batteries, of their engines, the health status. They need a machine learning here to tell them that, hey, you are doing fine, okay? Or maybe there is something wrong, potentially wrong here. You should go to check your battery, etc. So then you need some actionable decision here. That's why we need AI here, putting running here. The other thing is, I learned that when I was giving some talks, talking to the industry people, from the investment point of view for AI is, they found that the AI, if you continuously just train a model sitting in the cloud and then deploy it to the edge, then the model became more and more irrelevant. For example, when I visited Facebook the other day, we talk, you guys Facebook, what's their business? It's based on recommendation, right? Advertisement. So they found out that most of the recommendation models they trained in the data center, deployed to the different phones, the behavior is not as good as, one size fits all. So what they want is, can we have some personalized recommendation model so that we, cloud generate a model and then we deploy it there. Then you can do the local training, local inference, and then you can make more appropriate things for this particular user. So this is the challenge for them. So that's exactly what I'm saying here is AI impacts will be accelerated by edge computing with this rich data on your own, so that we can make a more appropriate recommendations for you. Give you a make an example here. For example, you are now in a temperature outside is 120 degrees right now. So obviously, what do you want? You need the water, you need a drink, you need this, you need many other things, right? So at this time, they can, based on the sensor of the temperature, they can sort of give you something, make some advertisement for you. So those are the things that potentially that the AI has been here. So assume you agree with me on that edge intelligence is important. Now you will ask that from a computer science point of view, what do you mean here? So here, this figure was drawn by one of my students. I have to give them credit. It's very creative on this. So this figure gives you a beautiful feature about what the edge intelligence is really about. For example, on the left side, you have traditional cloud, have a powerful server, very powerful, this PyTorch, TensorFlow kind of framework, machine learning framework. And then on top, you have different CAN, DAN, ResNet, different kind of algorithms, very complicated network. Now, when you move into edge, you pretty much have everything, but it's just at a smaller scale. For example, edge hardware, in Google, right? Google introduced the so-called TPU, and then ARM, Intel have this kind of small devices, and then in the middle you have NVIDIA just announced the Tensor RT8, 2 days ago, TensorFlow Lite, PyTorch Lite, and then not PyTorch Lite, but they might have some other names. So those are the small version of the framework plus a shrinked network for the intelligent algorithms. That's exactly give you a tangible view of what is edge intelligence about. So basically what you need to do is you need to have a small scale kind of things running here. And then because one edge is not enough, so you might need to do edge collaboration, edge cloud collaboration to support this. So this figure show you that how it works. Here is traditionally you collect data, sending to the cloud, and then the cloud, training a bigger model, putting into the edge, and then you do this face recognition, right? You realize them. But now, next thing in the edge computing today is after you get the model, you continuously collecting data, you do local training, and then you apply this to the edge inference. And this model, if you see have some meaningful for the parameters, you can even send it back to the cloud and then let them to continuously reinforce their concept. So that this figure shows that the future we call the CEI, collaborative edge intelligence. That you have cloud, edge, and they have things. Excuse me. A lot of collaborations could happen here, and then the issue is how to, again, I'm asking that if this is a scenario, how can I write a program on this? So can the system automatically deploy some function on the things, some function on the edge, some function on the cloud? So without something like this existed, it's very difficult to deploy this. So good news is in the community, LF Edge, sponsored by Linux Foundation, and also business companies such as Amazon, Microsoft, Google, they're working on this, produce a lot of these interesting frameworks, and then as an academia, we are not powerful enough to create things, but we can collaborate with them, define what is the potential architecture for the future. For example, we are working with AECC, Automotive Edge Computing Consortium, that we can make a proposal to them that what's the next generation architecture to do this type of things for the connected vehicle. Through these ways, you have a chance to impact the future industry and how it works. So that's, I think, that is more realistic, that make some open source and etc. So this figure gives you a sense about that the size. Let's pick a size of this model. Normally for machine learning model, for example, AlexNet, it could be cost like 240 megabytes. But this is too big for running on a small device like on your earbud, right? So One of the people introduced Dr. Han Song from MIT. He introduced SqueezeNet, which is only 4.8 megabytes. So that will be much smaller, can deploy in many places. But that's not the end of the story. In today, so we are actually looking for even another several out of magnitudes smaller, like a KB level of models. Can you deploy this on the tiny things? For example, on your phone, on your future light bulb, on your other stuff, then they can be automatically just running things on themselves. That was, going to be that the future of this, IoT edge, they are talking about. So I have to go a little bit in the next following, the rest of them. I will show you some of our research in this space, but I can only very quickly go through that to give you a taste about this. But if you are interested, you can go to my website, just download these papers. So about one of the earliest study on this was done by my group is on Hot Edge 18. If we want to know that, hey, you have so many models, packages, edge devices, is there, which one is good, which one is bad? This one is, the question was actually come from my conversation with industry partners. The industry is asking me that, hey, we want to develop an autonomous vehicle. So which package should I use? That question actually, nobody can easily answer that question today, right? So we starting to look at that, and then we compare them looking from the 4 metrics, such as the inference time, total time, memory footprint, because they need to decide how big is the memory and then the energy consumption of these models. And for example, I show you that here is the 2018 results. Okay, I have to that this was not like 2021 results because these things might be changed. For example, Cafe 2 is not existing anymore. Now it's merged with PyTorch. But you can see that nobody is good for everything, right? So they have different, depending on the metrics, on the different hardware, then you have different meanings on this. So this was our, observation here is really depend on your application requirements, and then you can choose the most appropriate models, hardwares, and then for you to use. So this actually is the beauty of that. So one of the former PhD students that, and we come out with this paper called the OpenEI framework. That basically is addressing this issue. Is that if this application people tell us your requirements, for example, how accurate latency, energy, and memory footprint, and then we propose a framework going to help you to make the choice for you and what hardware you should use. And then that how do you do, which framework are you going to be used to deploy that? And it turns out that this was a paper coming from a university industry collaboration, perfectly answer their question, but also allow us to writing a paper in this area, because this is a very important things, but we haven't seen too much paper has been talking about this. So that pretty much give you an idea that we have, from that we argue that the AI era is already sort of moving to the EI era, in the edge computing branch. So pretty much it's starting from this big data to big data 2.0, big model to the collaborative model, heavy frameworks, lightweight, and then general design to the domain specific. And then you can see that in our group, so we have been working on many of this, pretty much for all of this, we have some work has been done in the last, 5 or 6 years. So then I still have some time. I will talk a little bit about that in the CAV space. So before I turn to that, so I just want to, hang out here to ask, do you have any questions so far? If there are any questions regarding to the edge intelligence, more in general. Okay, so if there's no question, I will continue with that in the CAV space. So first, I want to share with you that because last time when I was give a talk in a place, and then somebody wrote to me and said, "Hey, I heard that you are not working on edge computing anymore. You started moving on the autonomous driving." And I said, "Oh, yeah, yes or no?" Because that autonomous driving is just one of the applications that edge computing has, can enable. So technically, I'm still working on edge computing. That's our strength. But we also started looking at in the CAV space. So give you an idea that why we choosing this area. One reason is obviously, as I showed you earlier, that we are in Detroit, Michigan is, the motor city. So we have a lot of expertise needs here in terms of the connected autonomous vehicles. But at the second time is that is a vision. We believe that the future vehicle, we recently drafted an article that I'm going to talk a little bit later. Here is on that the emergence of vehicle computing. Why? Because you need to think about look at this vehicle. We have this is our lab's vehicle. If you're looking for this guy, you can view it as a computer sitting on the wheel. That is the way we view it. For example, if you look at this guy, you can come with many sensors. Then you have a perception, to determine what's going on in the context, and then you make a decision how to drive and etc. and do this control and things. So if you're looking for all the sensor modules, and then underlying, you need to have an operating system here to manage them, and then you have a hardware computing platform here to do the computing. By the way, the trend in the auto industry is traditionally is many small ECUs, but there's a trend right now is a future vehicle will have a pretty small, less number, but it's much powerful computer to handle all these computing requirements in a vehicle. So if you're looking for that, that's perfect. That's where VMware, for example, you do the isolation, computing. Today afternoon I'm gonna have a meeting with the VMware talking about our collaboration with them. Is you probably never think about why VMware virtualization company is interested in a vehicle, but that's the future. You have a multiple applications running on a vehicle. How do you provide the isolation, safety, and etc. on these things? So in addition, this guy rely a lot on the cloud platform, right? For HD map, using that to determine the location and then to drive on the driving the models. And then that's the way I view vehicle. It's just for me, from my point of view, is that it is just a computing device here. And then this is not alone. And this guy will allow you to even talk into other things. So I'm going to show you another, the body cameras that, from weared by the law enforcement officers, for example. So the vehicle can also talk into the external people. So we are viewing that the future vehicle is not just need computing when the vehicle is in a move. So now we are talking about even vehicle is a parking here is still a computing devices. Have you thought about that? In the big cities now, when somebody is trying to deliver, doing a food deliver or deliver some other package for you, have you thought about net Amazon or net USPS, deliver your package to your car instead of deliver to your home? Because your car is anyway is already parked on the street. For them, it's much easier. They can just, if there is a way, allows them to open the trunk, putting your package in your trunk, then you are done. Those are something that, because the vehicle needs to do computing even when they were parking here. So that was the vision we have for the future vehicles. So now, with this as an overview, and then autonomous driving itself is very complicated. I don't want to, as you can see that nobody here can claim they know everything. We are just a very tip of that. You have to mechanic, you have to communication, hardware, and electrical engineering, mechanical engineering, etc. So that's why I like this one is because it's perfect, have all these disciplines working together because you have to, the earlier you started working with other disciplines, the earlier you're getting a good sense of this field and you can do some meaningful contributions to this. But from our side, I have to, from the computer science side is, here is a vision 2017 Intel produced. One autonomous vehicle every day will generate 4 terabytes of data, 4 terabytes of data. And then this is going to be every day. And now if you're looking for a real vehicle, which is running on the California road, already have a drive license, because of the safety requirements, they have to have redundancy and etc. That one even produce much more vehicle, much more data, such as 35 terabytes of data. And because of the much more devices they are putting there, even the maximum they can consume is like 5 kilowatts, with that. So those are the big challenges that we are talking about. Why autonomous vehicle is not ready to be passenger, go to the individual families, because this cost is crazy. Today, you can buy an autonomous vehicle ranging from $300,000 to $1 million. Again, the reason was because of the device is very expensive, but we believe that it will be done. Once as the more and more research has been doing, and also the size of the volume of the product. So this is our vision for the future CAV. Imagine that each of the vehicle can have a vehicle computing unit here, and then take care of all this computing here, and the data processing for the vehicle. And then on the roadside unit, we call it X Edge. It could be at the base station or roadside unit RSU. And then they also provide some more computing here. Those, for this small text, you don't need to read them, but just give you an idea that it's kind of a collaboration between the edge, between the vehicle, edge, and the cloud. This is the vision here. And then what we have doing here is by 2017 that we realized this important field, and I took the leader at Wayne State, starting this car lab. As you can see, my colleagues here, including people working on transportation, from civil engineer, real-time, embedded system, and then the cloud computing and energy efficiency, mechanical engineer, and etc. So that we have been very quickly, have more than 15, industry collaborators and been working with us. So most of the papers I'm talking about in the next minutes, you can easily find from our website. So since we created this, there's quite a few good news has been happening in at Wayne State in general. So first thing is we launched a Center for Advanced Mobility. As you can see that the building. I will talk a little bit more about this. And then we launched a international conference called the MetroCAD. This year, 2021 is already the 4th year, and always hosted at the Wayne State campus. But in Detroit, it makes a lot of sense. Normally we have about 70 to 80 people coming from the U.S. Sometimes we have people from Japan, Korea. They are flying here to deal with to attending this. We have the interesting thing here is we have demos, so you can really touch this kind of real autonomous vehicle and the shuttle and etc. So the other thing is recently we have teamed up with City of Detroit, University of Michigan, American Center for Mobility. We have won one of these 8 $7.5 million federal grant on the self-driving car development, team up with Ford. So we're gonna using Argo AI, Ford vehicle, and then to do the urban testing, autonomous driving, and etc. So myself, our lab is also working with a French autonomous driving company for the Michigan Mobility Challengers. The idea is that to have their shuttle to running during the International Auto Show, etc. So those are some news. And then the latest news, which was happening a couple of weeks ago, is that we recently being selected by National Science Foundation to create this industry university collaborative research center focused on the ECAT. What the ECAT stands for, this logo was to come out. Wayne State, we are taking the leader, and then University of North Texas and Clarkson University from New York, and then we formed this, an ECAT center. The idea is we're looking for real-time technology, infrastructure, perception, and communication, and then trying to, facilitate the collaboration with industry partners and etc. So this is just the beginning. So if you have come from industry partners, if you're interested to join us, part of this ECAT center, please, send me an email. So I will be very happy to talk to you. So myself is serving as the center director, and we will be, as I'm showing that this will be the facility that the IUCRC center will be, and actually all of our mobility, the vehicles, etc., will be moving to this relatively new facility to stimulate this was a new, facility Wayne State recently purchased called I2C, Industry Innovation Center, which is trying to stimulate the collaboration between industry and the university. So the first thing, as I mentioned earlier, that what is our vision about the vehicle's position? Why we are interested as a computer scientist, we are interested in this. So this figure shows you that even further looking, it's just published yesterday, officially on the IEEE Internet Computing. So that if you're looking for this, the vehicle is in the middle, and then vehicle have a computing equipment along with that. So obviously they can talk to each other, they can talk to the edge server, they can also talk to the cloud, right? But at the same time, the vehicle can also talk to the lower level IoT devices, for example, drones, body-on camera. So one of our projects that we have been funded by Department of Homeland Security is, during the law enforcement, when the police officer leaves the vehicle, they wear a body camera. So when they approaching some scenes, the body camera going to take the video images here and then wirelessly transmit it to to their vehicle. So the vehicle is very powerful, can do the real-time computing. They can know that what's going on with this scene. For example, if this vehicle is a stolen vehicle, then they will be putting a much cautious. The other thing is very important is that this is a real problem. Is in many cases, for example, for the firefighter, and in some cases, that when the firefighter get in the scene, people actually don't know what's their current stages, right? So the concept that we are doing on the edge, in this case, is on the fire trucks, so they can do the real-time computing in process this infrared images what this firefighter has seen in the scene, so that they can be much more prepared, can save their lives and etc. So that just show you an example that the vehicle is not just for when they are moving to do computing for themselves. Think about the vehicle itself will be as a computing platform to support the surrounding computings. So that was one of the we termed this called vehicle computing. So that was the view here. So now, in order to support this, the first thing, as you probably see from my presentation, is we always care about how do I write a program. So if by this time you might be convinced that, oh, got it, vehicle is more like the future smartphone. Because remember, smartphone original idea is a phone for you for a phone conversation. But today, smartphone, the way beyond that phone conversation. It's a computing platform, right? So you can do many, many things on that. So the reason why this is a success in the smartphone is because Apple, we have to attribute this to Apple. At the beginning, when they introduced smartphone, they have an open SDK, allow the third party to writing apps for that. So this way, that for example, if you want to write a program to reading from the vehicle, said, now I'm very smart. I want to come out with a product called a smart light. Why? Because today, if you're looking for a vehicle, or in last 100 years, the lighting on this, although they're changing to the LED and etc., nice. But from our engineering, computer science point of view, I didn't see there too much innovation there so far. What I want to do, actually, one of my students already sort of project implemented this idea is, how about the following? I'm driving my vehicle. If I see there is a human being, people, pedestrians working on the road, then we can reduce the strength, strength of the light. Because we all know that if you are the pedestrian working on on the street, you see a very strong light, you hate them, right? Because the eyes is really hurt. So why not they can do automatically detection on this? This idea is very simple. I believe in the future, maybe the next generation of the vehicles will be come with this function by default. But today, how do you do this? The idea is simple, but how can you implement this? First of all, you need to read the camera of the vehicle. Do you know how to read the camera from the vehicle? No, none of us knows, because the camera data will be collected through CAN bus or maybe through other channels. Nobody even opens this data source to you. So that was the first problem. But today, if you want to write a program for the iPhone or Android phone, it's very easy because they come with SDK. You have API. You can read. Okay, Gero, you can read all the sensors, right? You can do like all kinds of things available. But on the vehicle today, nothing like this available. You can't, although the idea is good. So that's come to why in 2017, we started working on this called Open VDAP. It's called Open Vehicular Data Analytics Platform. So recently, Ford is interested in collaborating with us. That's because of this. Because data analytics used to be in the cloud. Now we're talking about you want data analytics on the vehicle. But how do you do that? You need to have an API here. We call the Leap VDAP, which provide you the API so you can read all this sensing data. In addition to that, we also provide all the weather data, traffic data for you. For example, we're collaborating with Denso, provide us all of this accelerometer, all this type of driving behavior data, which allow us to develop a model called the P-beam. I'm going to show you later. It's a personalized driving behavior model because we develop model so that read the data from the vehicle, and then we can tell you that, okay, here is the driving behavior. We can tell you only high level. For example, this particular driver right now is disruptive driving, or this people right now is dozy, sleep. So in this case, you have many other applications that can benefit from this, right? For example, insurance company can say, you are in trouble. Maybe that was the way we are talking to with the AAA or State Farm. Or the vehicle company gonna say, wow, you are in danger. We want safely that. So we will remind you that please park in your car as soon as possible. Take a lap or somewhere. Don't drive anymore. Sort of like this to warning you. And those are the ideas that you have many new concepts can be do, but without such a platform available to you, you don't know how you can write a code on this. So on top of that, as we said here, you have 4 type of applications you can do for the future vehicle. ADAS, autonomous driving is obviously, but those most likely will be done by the OEM, by the company, car company. But then you can do infotainment, right? If you are not driving the vehicle, what are you going to do on the vehicle? You can have a conference, teleconference, natural language processing, and this is very important because you want to have a meeting there. And then the third part is, you can do a real-time diagnostic for the vehicles. So this is exactly, we have an ongoing project looking for the battery status. Can we, detect is there something wrong with the battery, and then we can remind the company said you have to deal with fix this as soon as possible. Engine, tire, many things. And then the third-party applications. For example, you can do many third-party applications. Imagine that in the future, your vehicle is just like today's smartphone. You can download a third-party application, deploy it on your vehicle, and then you get more functions. So the beautiful thing is for the OEMs is if you open this data to other people, you can like Apple today, you can charge money for the vehicle. You can say, if you want to deploy a application on this phone, on my vehicle, you need to pay 30% of your revenue to me because I provide the data. And then, just like today's mobile apps, how the business model is running. So that's the thing we are talking about. So in our car lab, we have been working on a full stack of things. For example, starting from a benchmarking platform for CAVs, machine learning on the heterogeneous platforms, operating system for the vehicles, collaborative cloud edge analytics, and then you have communication optimization, privacy, security, access of this data, and then you have some safety applications. So we have been working on this. So next, I will take a very quick snapshot on this project that we have been doing. Hydro One is a in-house developed platform. So as you can see from this list, that we have been working on this that from hardware all the way to the software, system software and application software, and etc. So now, first thing is when we decided working in this area, then we realize that on the on the market there is not many that open platform that we can use them to do this kind of research. And then we put effort immediately starting to develop on the left side, the Hydro One open source. We already open sourced this platform. We build this, by screw ourselves, including the control. This is all-wheel drive, by the way. And then we have this, control drive-by-wire by ourselves. And then on top of that, we put in this, LiDAR camera, etc. So this was the first platform we developed ourselves, which allow us to do many researches here. So that was the one for indoor. This one can only run in the indoor settings. And then recently, we developed another one on the right up. We call the Zebra T. Well, the first one is called Hydro One. Zebra T is for outdoor, for food delivery, but we use this for the, sort of like a slow speed kind of delivery so that you can run some experiments and etc. on that one. So we have been using this to support our research for the outdoor, but it's in a slow speed. The last one we have is for the fusion-based autonomous vehicle that we have been doing this is for the high speed. You can go to drive on the normal road and even highway to do this. So that was the first thing we have been doing. Research platforms. Without the platform, you can't really do the research here. So Hydra One, that we have a paper dedicated to describe this, how it works. The operating system is running is RAS and etc. I go a little bit fast on this. Here is our hardware design, including this. Everything is open source. So if you want, you can follow this and then build something by yourself. And then the Hydra platform is, for the fusion. The vehicle itself is, as I said, it's only costs about 10% of this of the cost. It's really about this, the sensors, the computing equipment, and etc. So we are very fortunate to working with the industry partners. Some of them donated these sensors to us to let us to build this stuff. So then the next thing here is goes to we have developed the first benchmark in the CAV space called the CAV bench, because we realize that if you want to work in this space, the first thing you need to do is you need to know that how good of this, how good of your either computing system, your algorithm, and etc. to evaluate either the hardware or software. So our CAV bench allow you all the way to evaluate even to the register level. How much that that register has been used, memory bandwidth, etc. to even design the computer chips for the future vehicles. And then we also developed this roadside unit to support this CV2X. And this week, another company recently just donated the CV2X equipment to us, which allow us to running this vehicle edge and kind of optimization. Right now we have DSRC, 5G plus the CV2X, the latest one, and then Wi-Fi, etc. So that was the what we have. In terms of the operating system, we are working on this. As I mentioned earlier, that you need to have a multiple applications running on the vehicle. So you need to support a certain amount of the features, so that other people can the application can run in that. So we are developing this Hydra OS. So this right now we're in the process of collaborating with the VMware that we're doing this. The other thing is we call the E2M. This is about the energy efficiency. The reason is, as I mentioned, that there is a lot of energy has been spent on the sensing part and the perception, part of the future electrical powered vehicle, battery powered vehicle. So it's very important for us to, how do we save the energy, etc. In this paper, is one of the earliest paper we identify how much energy is spending on the computing, how much is spending on the sensing, how much spending on the real driving, and then how do we do the optimization and etc. I have to just go a little fast. So if you're interested in this work, you can go to our website to look at them. And then we have a P-beam. This is exactly what I mentioned earlier. How do we develop this personalized driving behavior modeling? So you come up with a model from cloud and then moving to the edge, and then continues collecting data from the edge and eventually to be used. For example, this can be used for driver assistance, safe driving system, and even for credit rating for the insurance company that, for example, State Farm is in the process talking to us, to using this model for their purposes. And then most recently we have been working on is predictable machine learning. This is really related to, for the autonomous driving, that many machine learning, particularly DAA, has been used to do object detection, etc. However, remember, this is for the vehicle. We need to make sure that it is predictable. Otherwise, that maybe there is a disaster going to happen. So in this work, we have been looking inside every single function level that where this time spent for these machine learning models, and then we do the optimization to make sure that there is a in a real time and then it's a predictable latency that so that the machine learning can be used for the autonomous driving. So that was ongoing research on that with some other national labs. And this work is we call EV battery guard, is an NSF funded project. We're looking at how do we detect the failure of batteries. So we're working with an electrical company that donated this data about all the from campus, from the battery management system, as well as VCU, MCU, and then we're doing this analysis, trying to show them that how do we do this. And then one interesting thing is from this collaboration, we also published a paper on clone. It's called collaborative learning on the edge, because imagine that earlier today, I mentioned that you're going to running this on every individual vehicles. You have a lot of vehicles, and then how can you do this collaborative way to do this type of learning from these vehicles? It will be very useful. So that was the work we have doing. This was experimental platform in our lab. We have run this. We can't do this in a real vehicle, but we assume each of them will be a vehicle, and then we do this testing. Edge mapping, edge computing for the autonomous, for the high definition mapping that supporting this kind of driving things. So I think I will go a little bit fast. That I want to have some, leave some time for the questions. So NLU Brock is another work. We working on the natural language processing service. We found out, Google, Microsoft, Amazon, they all come with this kind of NLP engine. So we evaluate them, what's the performance of them, and then we can, dynamically choosing the best NLP service to support future, vehicle settings, or maybe the smart home. Try is another work for the home-based voice assistant system. How can we improve, by using the edge computing, for example, turn on the lights in the kitchen, and then how do you do this, and etc. That's what NLP work. And then a collaboration with the Bell Labs, we recently finished this work of vehicle edge compression framework. This is a very innovative idea that instead of sending all the videos back to them, we found out that you actually can do a compression before you send them. For example, right now, our best result is you can compression 10 frames into one frame, and then you can do the processing, and the results is almost the same accuracy as you processing all these 10 frames. And this work was, was great, and then that probably can be quickly deployed in some of these, applications in the vehicle. We are also in the process talking to some, industries and to use this technology. So the other one is we call the mobile edge on vehicles. This is the idea is that, right now, so far we're talking about the vehicle come with a very powerful computing unit. But keep in mind that all of us actually have a smartphone, and those phones are very smart, very powerful today. So why not that if we can give some of the tasks, not mission critical tasks, to running on the smartphones, right? So that, for example, my phone today, it costs like $1,000. You have a GPU, you have 80 cores, 8 cores, and etc. You can do a lot of things. So here is the way what we're thinking about. In the future when you're sitting on the vehicle, what happens is you traditionally you do this task, split it into general purpose AI computing on the vehicle. But then in the future, what you can do is the following. So it's going to be migrate some. Once you sit in there, we found out that your smartphone is available. We can run some code on your smartphone and then do this computing and to satisfy that, some requirement. And this probably can be very, useful to support that, the computing equipment cost for the OEMs. Because I recall that when I have a conversation with Toyota, they mentioned that they don't want to put in anything, that consuming more than 10 watts, on their vehicle. And then they also have a big budget, cap for the computing equipment. Because the more computing equipment they put on the vehicle, the margin for their profit is also going to be reduced. So those was the idea that, on this smartphone. And here, this one is showing, as I showed earlier today, using a body wear camera can talk into the vehicle and etc. So this was used by US NIST NIST. They're using our OpenVDAP as a reference architecture for the future law enforcement the implementation. So our demo actually has been went to NIST as used as for the public video analytics, for the public safety purposes. So that was one of the work. And the last thing I want to mention is, in addition to Wayne State, our campus, we also in our neighborhood here, we have access talking to MCT from University of Michigan, American Center for Mobility, that we can run some real testing. For example, we are working with our autonomous trucking company. Obviously, we don't have the facility to do any testing here, but we can work with ACM, to work on that. So we have a lot of ongoing research, collaboration with. Here I just list a few of them. Right now we have active collaboration with them, and we are more than welcome to working with other potential industry partners. And if you are interested in talking with us, last thing I want to mention is Wayne State is a very interesting, supporting this mobility initiative. And I had a news yesterday that we are very happy that Wayne Mobility Initiative was selected by Wayne State as one of these 7 bold move ideas. And I believe that will be, one of our strategic areas in the next 5 years. So I think that will be putting us in a very good shape, to have a big impact for the mobility space. We also do a lot of, education workforce, related to mobility, including a series of different programs, starting from online programs to the certificate, masters, and the PhDs, and etc. So I think here is a summary that the edge intelligence era is coming everywhere. You can use, and not just on the CIV space, but in today's talk, I'm spending some time on the CIVs that we are working on in the last few years, and we are open to the collaboration with anybody if you're interested in this. And I will stop here. And then sorry, I took in but we still have 5 minutes available. All of the papers are available on the Car Lab website. And if you have any other questions, you can feel free to write me an email, ask me. Okay, I think that we are open to take any questions from you guys. That feel free, just unmute yourself and ask it. Thank you. I will stop sharing here so that we can sort of getting an idea that we can see each other. All right. Thank you for the attention.
Thank you for your presentation.
Thank you. Any questions you want to ask and discussion? Okay. Seems like people are shy of asking questions. Normally, if I'm the host, if the audience was shy, so I will try to come out with a question. But today, since I'm the speaker myself, I can ask questions myself, right? So, okay. There's a question coming from Chris asking about can you let me see, it's quick moving. Where the quick goes so fast. Comment on the potential of federated AV. Are you mean federated learning, or you are talking about the multiple AV working together? Sorry, that I need to ask this. Xiaoxuan?
Yeah, sorry. I was going to typo federated learning, right? It's kind of a typo.
Oh, okay, good. Yes, I think that's a very good, very good, question. If you remember that I mentioned that we have a work we call a clone. Okay, that when we started working on this, federal learning was not haven't been not popular yet. Okay, but they do have a big difference between these two, though. Now go back to your question. Federal learning will be a very big thing for the on the AVs as well, and particularly, imagine that if you are Uber, Lyft, you have this a fleet, right? With a fleet of this, and I believe that autonomous vehicle, the first group of applications will be in the fleet deployment. And among this fleet deployment, they're going to have a very interesting collaborative analysis there. That will be federative learning could have a player there. Yeah, but they might be need to have some work, to reduce the traffic. So one thing is our clone and the federal learning difference is that federal learning right now is synchronous. You assume everybody online at the same time. When you're talking about the vehicle in the physical system, you have to be prepared that, you might have 15 people participate, but at any particular time, maybe only 2 people or 3 people are online. So how you going to be doing this asynchronous learning will be a challenge to apply federal learning here. Yeah. Okay.
Okay, thanks a lot. Great answer.
Okay. yeah, if you have any questions related to our educational program, you know, you know, the master's degrees, we have a new MS in robotics with a dedicated track on smart mobility hosted in computer science, intelligent control hosted in the ECE department, and industrial automation in the engineering technology. So if you're interested in this, that, you know, you can start in, you know, thinking about come to Wayne State to do this. I think the beauty, recently I have a student, his undergraduate degree is automotive engineering from Jining University, China. And then he did his EV in our EV program. And then now he moved into computer science, became a PhD in autonomous driving. So this kind of background, this kind of talent is what the world is need in the future. So I highly encourage people stay out of your comfortable zone. Think about to do these things. Although at the beginning it might be not an easy task because, you know, you need to learn much more than other you know, when you stay in the comfortable zone. But in reality, here is the more you know here, and then that you know, industry partners, they need this. If you are not asking question, I can share with you that there are several companies when they're talking to me, they said, we want to hire all of your students. You know, if you have a student graduate right now in our lab, there's a, you know, that this is something is very popular. I found that this is good. Okay, Dr. Tan has a question sort of related to open. I will discuss with you when you are free. Okay, yes. You know, I have to say that when we have the vision of open VDAP, I think that it was really an early stage because we come from computer science. I know that the open, you know, with the API, SDK is very important to make this happen to the community. But at the beginning, we're talking to the vehicle, they're not in that you know, the same, you know, what I say, the same page with me. But if you're looking for 2020, now the things change significantly. You know, GM this year in the CES, they have their own product talking about that. You know, if you're talking about Amazon and many other companies, Volkswagen, almost all the companies realize today they need something like that, because that's the key for them to one, you know, to make money. Because if they don't open the data out, their vehicle will be going to be in trouble. Because imagine us, you know, other people can start and download other applications running on the vehicle, can do a lot of functions, but your vehicle don't have that function. So what you're gonna lost the competitiveness in the, you know, in the market. So things are changing significantly. So that's why the last week when I give a talk at the Ford, there's a lot of questions coming to ask us about Open VDAP. Is whether Open VDAP working with AutoSAR and you know, and etc. So you know, that is something that yeah, we have been working on. Okay, I think that if there's no further question, I don't know if Lauren is still here. So I myself that I will make the announcement that you know, next week will be our last Jessup seminar series. Will be Dr. Helen Durand from chemical engineering talk about is related to chemical engineering work, but she's also working on the process machine learning stuff. So I encourage the people, if you work in that space, please, you know, looking at you know, attending her talk. And with that, I thank you all for your attention. You know, particularly that the people, you know, my colleagues here at from Wayne State, as well as the, you know, the audience from internationally who joined today with us. Thank you very much, and yeah, feel free to ask any questions. All right, bye bye.